Hi, good afternoon. Welcome to iUniversity, welcome to iTower, and welcome to Data Science Bootcamp. My name is Marcelino Lominchar. I'm Associate Director of Bootcamps, and today is the most special day for us, the most special day for our bootcampers. In this very first moment, I would like to thank to Ivan Martin as an academic director. Ivan Martin designed everything in this program, and probably we are talking about that he's the guilty that this program exists. And thank you so much to Barbara Fajardo as the coordinator of this program. Barbara set up everything, prepared everything in this program. Thank you so much, Barbara. And thank you so much to the professors because they are so essential for us. And thank you so much, obviously, for our bootcampers, for our students. Probably they are very nervous today, but they have worked very hard last 6 months. Probably they knew nothing about, I don't know, coding, machine learning, Python, even maths and stats 6 months ago. But today they are going to show us that they have learned last 6 months. I'm 100% that your presentations will be fantastic. And please enjoy this stage as, I don't know, as a red carpet, and please write a lot, okay? And we have a jury. We have a jury today. I would like to introduce you to the jury. Please, I need to read the first. And the first one of the members of this jury, we have Maria Anzola. Maria is Sales Director at Mogu. Mogu is a company or an app, mobile app for travel agencies. We have as well Laura Catalan. Laura is marketing digital expert and graphic designer at Applied IT, a data analysis company. And Inmaculada Navarro. Inmaculada is industrial engineering at Applied IT as well. And finally, Ivan Martin as an academic director and CTO at Beinfluencer. And now, Ivan, please, Ivan is going to explain to us that the projects that we are going to see today. Okay, Ivan, thank you.
Great. Thank you very much, Marcelino. So, guys, we've made it. We're here. Moment to shine. It's going to be those 15 minutes where the only reminder that I keep saying is remember that you guys are presenting and you've become experts at your project. So now everyone that is not part of your team will need that special taste when you guys are able to explain things properly, explain things so that they are understood by everybody, me included. I wanna say that as Martino was mentioning, 6 months ago, you guys were starting in the world of data science, and in just 6 months, you are able to do a project from beginning to end, as you will display today. Not only data science, I always say it's not only for fun, which it is fun, but it has to have value, And you guys have generated a project beginning to end and proven its value. We'll see the results today. And I just have to say that I'm very proud that you guys have reached this point, and I'm very ready for you guys to shine. So please, first group, Mogu, go to the stage.
Hello everyone and welcome aboard REST. REST stands for Retention Engine Solutions Team, where data science meets tranquility. Fasten your seatbelts as we embark on a journey where we pilot Mogu's way to customer retention. But first, let's talk about travel. So travel is not just about places, it's about dreams. And with Mogu, these dreams are just a click away. But for who? For Mogu's clients. In the travel industry, there are key players. 3 of them are Mogu's clients. So we have travel agencies, destination management companies, and tour operators. And they all share a common goal. Well, various common goals. So first, creating engaging content. Then we have managing efficiently payments. And then, of course, offer the traveler support. So this all-in-one solution helps these companies succeed. But let's take an example. So we have my friend Marisa, who wanted to have a destination wedding. So she reached out to the travel agency, and thanks to Mogu, they gave her basically a detailed itinerary with all that she needed to know. Then they managed all of the payments through Mogu's app, and also made the big day just hassle and stress-free. So Marisa did enjoy it very, very much.
Thank you, Sofia. Now I'm going to talk to you about how Mogu's business model works. Okay, basically Mogu has two types of income, of main incomes: a subscription fee one, which provides a commercial proposal builder, as we are seeing in the demo here. So this is us really building a proposal. So as you can see, it's like really user-friendly, drag and drop, so really powerful tool. And still within the subscription fee, we can see that they offer to their clients, the ones that Sophia were mentioning, a travel support app. And in here, basically, the traveler itself will have the possibility to consult all the information that he needs in the palm of his hands. As a second main income for Mogu from their business model is offering an integrating payment solution. Okay, so basically Mogu monetizes through a commission based on the transactions that are made all in the platform in the very user-friendly integrated way. So as any other company, every company has its own journey, and in here we can see that Mogu started on 2020 and have several milestones. And we can focus on this first one. On their first year, they won an award for tourism innovation, which is quite impressive.
But let's move from how Mogu operates to how we at Rest will help Mogu to succeed. We are the Rest team. So we have Juan Luis Rio Perez, Omar Harradi, Patricio Carapito, and joining us remotely is Pablo Molleda. I am Sofia Peleteiro, and let's pilot Mogu's way to customer retention.
Thank you. So at Rest, we want to be the pilots leading the way. The solution we're presenting today, we hope that becomes a key business tool for you. Our main goal here is to help Mogu increase customer loyalty by predicting churn.
And why this is so important? As Forbes says, acquiring a new customer can cost up to 5 times more than retaining an old one. So for us, it's a pretty major thing to try to achieve.
Thank you, Patricio. But what is churn exactly? So let's say that you have a Netflix subscription, and imagine that you decide to stop paying this Netflix subscription and you cancel it. So this is churn. It's basically when a client leaves a company. And let's apply this concept to Mogu. So Mogu's client pay a subscription fee to access Mogu's services. And imagine that Mogu had 100 clients subscribed at the beginning of the month of May. By the end of the month of May, 5 clients left the company. So according to the formula of the churn rate, which is the total number of clients that left over the total number of clients at the beginning of the month, the churn rate for Mogu for the month of May is then 5%. And we aim to keep this churn rate as low as possible.
The strategy that we have followed started by consolidating all the data that Mogu had into a single large data set. We can call it an Excel file if you want. So this allows Mogu to integrate this model into their existing systems in a way that is straightforward and feasible. Then we clean the data, so it's more comprehensive, and that would allow you as well to make periodic updates, incorporating new customers, new subscriptions for further analysis, for future analysis. we have developed a tool based on machine learning, applying advanced statistical concepts. And finally, we arrive to our solution we are going to describe in a minute that will allow you to continuously monitor your clients' next steps.
Information is power. By giving Mogu precise information, we empower them to make strategic decisions. As agreed with Mogu, our analysis was based on unique customer IDs. We also decided to consider as churn customers only those who have not returned to Mogu within a 200-day period. During this time frame, we leave the door open for them to come back. In addition, we exclude from our analysis three types of customers: the trial users who never pay, the clients acquired by third-party partnerships, and users that had plans at zero cost.
So, based on those criteria that Pablo just mentioned, that actually were agreed with Mogu, and with all the complex stuff that Juan Luis was able to explain very simply, we got our final analysis focused on 517 different customers' IDs. Okay?
But before going into the data, let's remember that knowing the past allows us to understand the present and make better decisions for the future. So if I ask you or anyone, what factors would you think that are more crucial for Mogu's clients' engagement? Would you say it's the good functionalities or a lower price? Which ones are more important? Well, let's have a look at this graph. Based on our analysis, we see that premium customers are more loyal. That's clear. On the other side of the graph, we see basic plan customers churn more. So we wanted to look at the amount that customers spend monthly on average, just to see if this holds. And we see the same message, that high lifetime premium customers exhibit greater loyalty. If we look at the churn rates across time, we're showing here 2022 and 2023. We can see 2022 is not a very representative year because it shows the first steps in Mogu's history. But we still can see a pattern, although volatile, because churn rate is volatile, but we can still see a pattern with high rates in around January and July, which might have a message for us.
Now let's talk about the machine learning part. And don't worry, we'll keep it as simple as possible. So our goal with this model was to identify which customer is going to stop using Mogu services and which won't. And our final model was an XGBoost. We evaluated our model based on different metrics, but I'm going to present to you two of them. First, the balanced accuracy. It gives us a comprehensive view of the model's performance, considering both churn and non-churn equally. So a balanced accuracy of 88% means that our model identifies very well the customers that churned and those who didn't. On the other hand, the recall measures the model's ability to identify the customers that churned. And the recall of 96% means that our model correctly identified 96% of all the customers that churned. This ensures that we identify nearly all the at-risk customers so that you can take proactive steps and retain them. I'm going to explain to you the confusion matrix to better understand these metrics. So it's a very simple table that shows how the model performed. And on this green circle, you can see the number of customers that were correctly identified as non-churned and churned. And on this red circle, on these red squares, it's the number of customers that were wrongly classified. So we aim to maximize the green squares while minimizing the red ones. Now let's have a look at the 16. It means that 16 customers were identified as churned while they didn't churn. But when you think about it, it's not a costly mistake, because believing that a customer will leave the company while he didn't is okay. On the other hand, believing that a customer won't leave the company but he left is a very costly mistake. So out of the 25 customers that churned in that case, 24 of them were correctly identified by our model and only one was misclassified, hence the recall of 96%.
Now, let's navigate forward with Captain's Dashboard, your compass to loyalty. With this dashboard, Mogu navigates away from churn and cruises toward lasting customer connections. It is as easy as Mogu platform for its clients. As you can see, it allows us to filter by date and also by customer ID. After that, it shows those customers who have churned, and also key details, such as the country where they operate, their monthly revenue, their business type, and their most recent plan.
Now you
For
can
final
see.
review, I
Go
would
on,
like to
Pablo.
present the Churn Alert dashboard. This cutting-edge tool is your early warning system for your customer retention, catching any sign of trouble before they become problems. Omar will explain you how it works.
Yeah, thank you, Pablo. So it's very simple. We've established a traffic light system based on the probability that the model outputs. And based on that, red flag means that there is a high probability of churn. Yellow means that you should keep an eye on this customer. And finally, green means that there is a low probability of churn for this customer.
So now we've looked at the solution. Let's have a look at the economic impact. Churn doesn't mean just fewer subscriptions. It means it hits revenue too. So we can see here in blue the number of customers lost, and in red the revenue that has been lost due to churn. If we look into these two quarters selected in highlighted in yellow, we can see that there's no direct correlation. We have fewer customers in Q2 of 2023 with a high revenue lost, and the opposite. So it doesn't mean that having twice as many customers lost, the revenue will be higher. So that means two things. One is that not every customer contributes to the revenue equally. And the second thing, and most important thing, is that we recommend you to measure and monitor both metrics at the same time.
Thank you, Juan Luis. So remember that we spoke that we should look at the past to understand the present. So this is the past, okay? And we have two big numbers in here. The percentage of churn rate for 2022 and 2023, and the lost income for the same years, okay? So it's the total amount that was lost due to those customers who churned. So focusing on 2023 as a baseline, let's do some forecast, okay? What if from the 9 I get to a 7% churn rate? That would mean that Mogu would save 2,400 euros by this reduction, this more conservative scenario. If we pass from a more optimistic one and go from a 9 to a 5% churn rate, that would mean nearly 5,000 euros in savings. But let's give it some scale, okay? What if, and concentrating in this case on a revenue around 150,000 euros, that would mean nearly 7,000 euros in savings for the conservative scenario and nearly 13,000 euros in the more optimistic one, okay? But as I mentioned before, the baseline was 2023, and we didn't incorporate any growth in it, which normally doesn't happen, and we hope it doesn't. So we hope that you will continue to grow. So in this exercise, let's assume still in the conservative scenario, a 10% business growth. So that would mean that Mogu would save 7,000 euros, nearly the triple as the number that I showed before, okay? But I'm not done. This amount, and in this exercise, divided by the total revenue, it means that Mogu would be saving 12% of its total revenue, which is quite a bigger number. And what we as a team are trying to provide is a solution for you, Mogu, to be able to make those numbers a real number or even better.
Remember, the sky is the limit for growth and satisfaction. We leave the floor open to questions, and thank you for flying with REST today.
Great, guys. Congratulations. We're going to start by the questions from the jury. Would you like to start?
Sure.
Hi. First of all, I think it was a very great presentation. I do have to say and admit that our data was very messy, and I know you guys had a very hard time with it, so I think it's great that you could get results from what we shared. I have a lot of questions, but I know I'm limited to one. So I think I'm kind of interested in knowing whether you guys considered the amount of time that the customers were with us in the churn rate and whether that had any impact. It's okay if you didn't, but I'm just curious to see if that was included. And if not, if you guys could summarize like what you see as the main variable for the churn, that would also be useful.
Thank you for the question. So we actually have an appendix that could help answer that. Let me show it to you. So, okay, this is the feature importance, and that's the most important factors for our model to give the predictions. And concerning your first question about the paying period length per customer, we do have this variable and we use it. And it's not here directly, but it's among some of the most important features for the model. So yeah, we do have the feature impacts on the model, and you can maybe focus on these areas to improve retention. Does that answer your question?
Yeah, it does. Perfect. Thank you. I'm assuming that if it's not in this table, it's lower, right? So
yeah,
it's not.
exactly.
Okay, perfect. Yeah, that's good.
Go for another question. That's okay.
I mean, I didn't write them down. It's okay. Go ahead. If I think about the next one,
So, can you hear me well? Yeah, right. Thank you very much for the presentation. It was very interesting. I didn't know anything about this company before. I love traveling, so it was super interesting to me. Now I want to use the app and see maybe I could be one of the ideas that you have considered in the future. And one of my questions was about retention time, but you already asked it because I think it's very interesting to see, depending on the customer, how long it stays with you. And then I have another question. You showed a graph where you have some peaks in January and July. You mentioned that you clearly could see a trend there. And my question is if you have any clue or idea why these peaks happen there, or if you were able to correlate them with other parameters that you have in your data set.
Yeah, thank you for your question. Basically, the pattern is there. The problem is that there's not a lot of time we can analyze. This is all we have. We can analyze because of that 200 days that we have to wait until we decide. That 200 days we leave the door open for customers to come back. Then churn is the data we have for churn is up until November. Okay, and answering your question, the first peak, for example, the one in March 2022, that's affected by small fluctuations in customers, because at the beginning the number of customers was not that high, and therefore just a small amount of customers moving has a significant impact in that. That explains that peak. yeah, the others are just around those dates. That's what data shows.
Okay, thank you.
Well, yes, just a moment. So we have to remember we are in the travel industry. So when related to Mogu, their customers are travel agencies, as we were saying. So we see peaks in churn after the seasons of vacation, basically. Yeah. So because of what Juan Luis said, we have not enough data to measure in time. We cannot say it's seasonality, but we can clearly see a pattern.
Yeah, I was thinking it's January and July, so I would expect the peaks in February and September,
but
October.
But
that's why this is interesting to dig more into it. If you have more data, I don't know your data set, your raw data, but it's interesting. It's a clear pattern there.
Yes, exactly. Actually, that what you're saying, it is because the 200 days window.
It's shifted.
Exactly. You have to calculate to think 200 days prior, more or less.
Okay, thank you very much.
If we had a different window of 200 days, we would have a lot more peaks. Okay, so maybe we could identify differently what you're asking.
Okay, thank you. Okay, so I will ask her question. Okay. Also, you showed us at the end some traffic lights, like a prediction model, and maybe you explained, but I know you have concentrated a lot of information only in 15 minutes, and maybe you didn't have the time that you decided to explain everything. So if you can go back to these traffic lights and explain which parameters define the colors.
Of course. So the model we've built output a probability, which is the probability that the customer will churn, and based on a threshold that we established, the red means that there is a high chance of churn, meaning that the probability is very high for this customer to churn, and the yellow means that Mogu should keep an eye on this customer. Green means that the probability is low. So we believe it's a very useful tool just to monitor customers.
Yeah, my question is based on what you define green, yellow, or so. For example, retain. So how long has been the person or the customer in the or paying the service or the subscription, or how many travels have you booked, or I don't know.
So I understand your question. It's directly based on the probability that the model outputs, and the probability of the model is based on many factors that you said just now.
Okay.
So yeah, on around 20 features, something like that.
That's a lot.
Yeah.
Okay. Thank you.
Thank you.
Great, guys. Really good presentation. Very well explained. So usually churn projects in general, when companies do churn projects, is because what they do is they grow, and then at some point, like, hey, we've put so much effort into growing and we spend so much money and we're losing customers, let's try to stop that. But a company like Mogu is doing that at the very beginning stage, no? When they're still at the beginning phase of growing, which means that they will try to solve the issues that will cause the churn in the future now. No? And everyone that they save now with this churn model will then be piled up with future people that sign up. Well, so it's a very, very good strategy. So let's say you guys have these orange ones, which are people to keep an eye on. So what? What would you do different from someone who's orange to someone who's red?
We actually, our project, as you know, was based on getting this, but we thought a lot of probable reasons of this to happen, of probable strategies for Mogus to implement. But since it wasn't the objective, we haven't put them. But we discussed as a group that if we got a little other types of variables that we could, for instance, identify the time of usage of those customers, that might relate us with plus the other variables, that those customers are at risk because, for instance, they are not using that much the tool. So then, if we can include in the next steps some of these variables and retrain the model, maybe it could be easy to understand why. Because at this point, as Omar was saying, we're basing on around 20 features, okay? And some of them are kind of demographic, and some of them are financially purely. So I don't know if I answer your question.
Yeah, so
I will complement, because for instance, this dashboard, it is focused for the sales team. So when we see a customer in red, well, okay, high probability of churning, we have to take into account what kind of plan is this customer on, the time that they spend on the app, so we can focus on customer satisfaction and engagement. So, for instance, if I am a customer in a basic plan, I have basic features. So, of course, maybe that features are not satisfying my needs as a customer, but here's when Mogu sales team comes up and says, well, wait, we have a special promotion just for you in which you get the premium plan half the price. That is where this tool is very useful. That is the entire focus on our presentation, give a solution.
Can I just add
of course.
to that? Because if you identify, for example, related to that, but applying a more generic approach, if you identify that basic plans are lacking a special functionality that can hook, that can capture, that you identify as one of the most important or useful functionality for those customers, maybe that's the way to go, and then basically increase retention on those specific basic plans.
So imagine you could go back in time to the beginning of your data set, right at the beginning. Which variable would you have loved to have recorded throughout all of this period? Like, what would have improved your model and your project by a lot if you had it?
I would say the usage time, because we suspect, okay, we cannot prove it, but if you can see in the market actually that lots of softwares are offered for free trials, but it doesn't mean that the customer usually actually tries them. So if we have a variable that could lead us to know, are you using the trial period, yes or no? And act upon it so that we make sure that he experienced what we experienced, okay, because it was us who built some proposal and we know how it is to build a proposal. So that would lead to Mogu some time to maybe anticipate and try to immediately make sure that he has the proper information to deal with the tool and he's actually using the trial. If not, it's like when you get things for free, sometimes you don't value it. And if you can monitor that he actually not using, it's a sign that you should do something.
Great, guys. Thank you very much and congratulations.
Thanks to you.
So for the second group, Applied IT can take the stage.
Good afternoon, everyone. We're Volta, a consultancy firm specialized in energy data solutions. We name ourselves after Alessandro Volta, which was the creator of the batteries. As well, the voltages are named after him. But what we liked the most about Alessandro was actually his mindset. According to Alessandro, the history of scientific discovery is a history of obstacles overcome. So which are our obstacles of this project, and who are the main characters of this project? But for the records, we're going to get a little bit technical in here, but thanks to the visualizations, everything will run really smoothly. The first character that we have is an automotive car company that they have opened a new plant. Why? Because they are shifting their strategy from gas cars to electrical cars. In order to do it, that new plant that they have opened, they have two challenges in 2 stations. The first one is the one that you're seeing right here, where the robots place 12 module batteries, and each module battery needs 4 screws. So in total, we have 12 module batteries and 48 screws. As a result, for the moment, they have a 38% of not okays. The next challenge is in the next station. The next station, what we do is place 12 connectors among the batteries and cells and the trolley. The next character that we have in here is Applied IT. Applied IT is a company from the south of Spain. They are based in Cádiz, and they are experts in solving data analysis on real time. But they are also experts in the Industry 4.0. They are working with several companies such as HLT, Continental, or VMV. Actually, I encourage you, for the people that are at home, to go to this QR at the end of the presentation and see all the software that Applied IT has, because you will know how they capitalize the data and how, capitalizing your data, you can actually have more innards. And lastly, you might be thinking, so Volta, Applied IT, well, we decided to join forces in order to solve those challenges. And now I introduce you the main characters, and I would like to introduce you now the supporting actors, who are not going to power up your data, but they are going to power up as well this presentation. And we have Tomás González, Mirko Abasowski, myself, Guillermo Rodríguez, and Matías Orozco, who is going to show you the process.
So basically, as Guillermo said, the process is going to be very complicated, so we decided to make it as so simple as possible so you to understand. So basically, we have Station A. Station A is compounded with 3 different stations, where, as Guillermo said, it's the placing of the battery and the 48 screws. As you see there, we can see the 2 robots, in this case there were 3 also, that they work in parallel to place the battery in those modules and the different connectors. And then you have the trolley. So basically the trolley is going to move from Station A to Station B. But wait, maybe the battery is not okay because the result of the station is not perfect. So our engineer, Alexander, is going to come and fix it. And then move to Station B, where we have 2 modules, so B1 and B2, also working in parallel. In this case, we place 12 connectors and we place 2 screws. As you see there, we have the 12 connectors and the 2 screws. And then, if the battery is okay, it will move on to fit inside our final car, where our automotive company wants to fix all of these problems, because if not, they need extra time, extra money, and they are not inputting cars out of their company. So basically, what did we do? So first we use a classifying model called XGBoost. For those who don't know, that have no idea about machine learning models, basically imagine you want to predict the amount of balls inside a box. And you're competing with a friend of yours, but you need a very smart friend who knows what variables to understand to know that the amount of balls in that box. XGBoost is your smart friend. It will analyze every variable, the size of the balls, the width of the box, the height, everything. And it will tell you which is the most important variables that affect the size of the box. In our case, it would be what affects the okay or not okay of every battery in the factory. So that's where SHAP comes. SHAP is a describing software that basically measures the importance of each variable in your result. So in this case, it allows us to measure the importance of each variable on the final result, which is basically the okay and not okay. And we will see that Station A and Station B have very similar variables that affect each other. So basically, as you can see, position and screw are present in both stations, because both robots do the same, position and screw, with their differences in both stations, but they do the same. The counter holding, you also see them in both stations, which is basically where the robot handles the battery, and we can also see afterwards in our presentation how this affects our model. In the first station, we can see the career round trips. Basically, this is the amount of trips that the trolley made, and we are able to know how many trips, the ID of the card, so we were able to also to analyze this. And in the Station B, as you may see, we have a camera that measures the placing of each connector and the placing of each screw. So we were able also to have like an X and Y grid, as you maybe remember from math, where we were able to know where was each screw at each moment in the whole process.
Now let's talk about one of our principles, who is the screw. The screw is composed by the angle and also the torque. The torque is the measures of rotation force applied to an object, and we need to have the torque and the angle in a threshold. If the threshold is not between the min and the max, it's not going to work, and we need to have both torque and angle okay to have the screw fully okay. After that, now we are going to talk about data, so please don't get dizzy about the graphs. Okay, the first one, you are seeing here the torque of the station A, and you have here the 48 screws that Guillermo present. So here you have in blue the okays, in red the not okays, and in a blue line the thresholds, the min and the max. What we want to achieve here is to increase the accuracy. For what? To have more okays and to try to have less errors. As you can see, the okays are in a smaller range than the one that we have. After the torque, we have the angle. The angle is exactly the same with different numbers, so maybe we don't need to say a lot about it. But it's also to change the threshold and increase the accuracy. What's the point here? Maybe you see some red points inside the threshold. Why happened that? What we see is that when we have not okay on one of them, is because one torque or angle is outside of the threshold. For example, in this one you have that screw inside the torque but outside the angle. And if one is not okay, the final result is not okay. Go now to the station B. Here is the same, but we find that the OK results are more concentrated if we give a torque higher than 4.5. So why don't do it? It's like an easy way to upgrade the results. Also, with the angle, by reducing also min and max threshold, we are going to have higher results.
Also, as I mentioned before, we have the career round trips. So basically, this is the trolley that we saw in our visualizations. And basically, we see this works like a Roomba. I don't know if you have Roombas at home, but basically, it learns through time the spacing. In this case, it will know and will achieve less errors a long time, as we can see here. So first, when the plant got started in February, it had less errors because of the trolley than now in June. That it's probably more due to like the spacing and the screwing of the screws more than just a career round trip, because the Roomba goes in another way. And also, as I mentioned before, we have the X and Y in station B. It's a very similar analysis to what we did with the torque and the angle, but in this case, as you see there, the camera that's on top of the trolley will measure the X and Y of each screw. So basically, in the position 4, here we can see how basically in the top part we can see the most amount of not okays, and in the lower part we can see the most part of okay. So basically, here we can even prevent before the part is not okay to take it out of the process, because basically, as the camera is going to measure in real time, if it's from, for example, 0 to minus 0.6, it will be okay. And if it's out of that range, we can even take it out of the process and say already it's not okay, and Alexander is going to have more time to be more efficient, and we can even input more batteries. So what would you need if you were Alexander? So now Thomas is going to explain what would you need.
Okay, so imagine that you start your week, is Monday morning, you arrive your work, and your boss is asking for some data about the last week. So you can't not stay like extracting it manually every week, because you're going to spend a lot of time. Because of that, we want to support Apply IT with a dashboard to simplify that job. Here we are seeing the results for the station A, and at the top right you can see a filter when, for example, let's choose a full week from 13 to 19 of May. Then the whole dashboard is going to be updated, and now we can also choose which of the stations we want to see. In this example is the A.2. You can see the OKs, not OKs, the ratio, and also how many OKs and not OKs we have by day. After that, we have at the left the real ratio that we are having by now and their fully objective, who is 95%. As we need to know the whole results from the first week to the last one we have data, why don't we add a time series to see it? So we can compare every week, and when we do a change, we're going to see it easily. At the last part, we have some individual results when we have the unique trolley ID and also the product ID. Why? Because we can click, for example, in one ID for the trolley, and the whole dashboard will be updated. And then it's really easy to know if something is wrong about one of the parts. And now Mirko is going to continue.
Great, thank you, Thomas. Okay, so we've seen a lot of data, we've seen a lot of stations, but the question is, how does this impact the business? And how can we use all this data to actually bring some real changes to the factory so that we can increase that efficiency that we were talking about? And the first thing to keep in mind right here is that we found that by applying more torque and a better angle, you can increase your efficiency by 24%. And this is very important because these are some tweaks that you can do to the robots, adjust the limits in the torque, in the angle, and based on estimates we did, we see that we can increase that efficiency rate by 24% points. This is very interesting because when you translate this to monetary benefits, you see that this 24% more efficiency translate more or less with some assumptions into 400 plus batteries that you will be producing per month. If you assume that you sell these batteries, this means that you're producing 7 million plus per month. And this is great because at the end of the day, as a business, you want to sell more. But naturally, you also want to diminish your costs, especially because this is a production that is going to happen en masse. So automation of this process is crucial, and with automation comes diminishing costs. In this case, if you produce less 400 not OKs, and you assume that it takes 10 minutes on average, you quantify that, you will be saving more or less 30,000 euros per month, which has a great impact on the business. So finally, what do we need to do now? How do we achieve this impact? Well, the first thing to do would be to plan a small experiment and see if by adjusting these limits that we talked about, we actually get the result that we're predicting. Then we can move on and explore new variables. In this case, we see that there's a holding variable. It's a variable that takes the pieces, the robot, and see what's happening with that variable, see if we can improve it. And finally, analyze the effect that time has on the process. Because the question is if we increase the speed at which we're producing batteries, will we get more not OKs? And that's something very interesting and something that we would love to analyze. Well, thank you very much. And we hope that you enjoy the presentation. And if you have any questions, we will gladly answer them.
Amazing job, guys. Can we start with the questions?
Yeah. So thank you very much. I'm impressed with the presentation. I think you did a great job. I know you have worked a lot, and to me it's working professionally and studying, being involved in this kind of bootcamp, showing that interest. This has a great value to me. So be very proud of yourself and very happy. I know you have worked very hard during this last month. We have been working together on that. And so really appreciate the interest and the efforts you have made. The presentation is great. I saw a little bit of it, but it's amazing how you have made it dynamic. I'm super impressed. I was telling to Laura, she's the expert in marketing and design. This was great. And I don't have too many questions because I think you have covered everything perfectly since the beginning to the end. We gave you a data set that was horrible. More than one stations combined, hundreds of parameters, and you are working on a real project. So this is something that is really happening, and we are working on it, as Applied IT is working on it as well. So it's super complicated to get into the data, to understand the process, and to have results in such a short time as you did. So I don't have too much to say. Just one small question. If you can show the diagram where you see the stations, so the station A, station B, paths between these stations. Maybe you have had a look, or you know if between these back. Yeah.
This one?
No, the one before. Yeah, that one. Yeah. Meanwhile, you have different lines in each station and different stations. So, do you know if there's any relationship between the stations or contrast between the lines?
If we take a look at the video, you will see how.
Mike.
Yeah. If we take a look at the video, you will see how sometimes the trolley goes to A1 from A1 to B2, and then the trolley goes from A3 to a B1. So, as you are asking, no, they just go, once they finish, they go to the next stage, to the station that is actually with no trolleys.
Yeah. My question was more directed into the how they work. If there are contrasts in the quality rate between stations, and so line to line, same station, station to station.
So basically, we also did an analysis to how it changed from, for example, if you went from A2 to B2 or from A2 to B1, that even changed. We even saw that, for example, in the case of B2 and the station B is the one that has most fails from B1 and B2. And the combination that goes worse from the two is even A1 to B2. That has like the most amount of mistakes in the whole batteries. So even changing like from when it comes from for each station, it changes for the model. We even did a machine learning model. I don't know if we've told you, but basically we grabbed all of the data from station A and we only used the result of station B. So basically we analyzed how the variables from station A affected station B. We got the same results as the station separated. So it was everything or angle or torque or placing. So basically we saw that effect. So then we measured, okay, like how does it affect if it goes from A1 to B2 or A1 to B1 and those changes, and the percentages actually change. So yeah, each station has its own kind of life in a way. But as Guillermo said, so there's no preference if going to B1 or B2. It's just if the robot is free, the trolley will go to the robot that it's free. And even it's actually curious that if you see the combination that has the most mistakes is the combination where most of the parts went in. So that's actually was interesting, and maybe that was Ima, you even told us because it was of the quality of that kind of combination. So yeah, that was even a variable that we could even understand, but the data didn't have the quality variable. So yeah.
Okay, so that would be all from our side. Great job, great, really amazing.
I think your presentation was really great. I don't have that much experience in the automotive industry. I guess one of my questions is, I think the model is very interesting in terms of how you guys could predict the angle and what parts of the system. And I was wondering what other variables you think might affect or that you could incorporate into the model. For example, I'm not sure if there would be a correlation with like how old the machines are or what time of day they start or how long they have been operating. I don't know if that's something you considered, like whether after 6 hours of operation there are more mistakes versus the beginning. Just out of curiosity, I don't know if that's data you had or would relate.
We were wondering to have more variables. We measure each one of them, and we even wanted more because at the end there were so many things that could affect the total result that we don't know exactly which percent correspond to each variable. In the case, for instance, of screw, we know exactly which one, but in this case of position is a mix of everything.
Yeah.
So yes, according to what you're saying, for instance, in the station B, the red ones, we don't have, for instance, the force in which the robot grabs the battery, grabs in this case the connectors. So it would be more interesting to have those data. And
You can't have it all. Yeah,
of
it was
course
good.
we
It was
want
good.
to maybe have the temperature of the factory or the wind. We don't know, but of course there were many things that if we could actually analyze everything, it would be amazing.
That's all I have.
Great, guys. Good job. Okay, so one of the things that I think you guys, it was included in this presentation and in different aspects, was the fact that this is a process that's starting up. No? You had this graph where you could see the improvement of the process. Of course, optimizing how to do it manually more efficiently, it's kind of, it should not be necessary. No, so 2 years down the line, this should be fully automated and only trying to tweak the last ones they're not available. No, so how was it? How would you describe? Because it's usually in data science, you usually have projects where you have 3 years of data, and then with 3 years of data, you do some analysis, and some things very nice. No, but in this group as well, we had a process which at the beginning, the errors were high, but because nothing was adjusted. No? How do you think you could deliver the information to Alexander so that he not only can imagine they fix the torque and they fix the screw, what else down the line? No? Like, how could we prioritize the data or the information or deliver it to them? Here's an Excel file for you, the dashboard, but how do you stop and deliver that information to the Alexander?
So basically what we did is for every analysis, we of course, for example, the placing. In the placing, we had 48 screws, and each analysis for 8 screws. We have files of the 48 graphs if you want to see them. We have everything. Even the dashboard, Thomas can share it to you, or because even it helps for you because maybe you talk to the engineer and see the changes. Like for example, the other day, one of the variables that we mentioned was the placing. So basically, we even did kind of a graph where you see where the camera was placing each machine, and it was kind of one on top of the other, but it was just one camera. So basically, it was, of course, something was going to be wrong, and you even told us that the centers of the camera were wrong. So basically, that was kind of one of our predictions. So basically, give Alexander the dashboard, give all of the graphs that he can handle of all the screws of both stations, and then even give him some variables that he could analyze or change. For example, the cameras, or for example, even try measuring the quality that Ima said was important. Or even some variables that he shouldn't take into account, because of course the both of the data and both of the 2 stations, they had like 3,000 features, and it's very difficult to understand. So basically, even give them like a glossary of what is each column, because to understand each column was kind of the hardest challenge of the data. Not the cleaning, because it was just numbers, but then each column has like its own specific kind of nomenclature. And understanding that was kind of the challenge. And I feel like even for Alexander, which he can be an expert, I'm an engineer, Ima is an engineer. So basically, for me, it was even hard to try to understand the data. And I guess anyone who's not familiar with the sensor or with the manual, of course, of each machine, to try and learn everything that is pretty hard. So basically, even give him a glossary for each kind of variable. So that's why we basically also, for you, we changed to station A to station B. In reality, it was ST120 and ST160 and 160.1 and 160.2, but we made it user-friendly for everything. So yeah, Alexander could even have the same kind of user-friendly dashboard, because even maybe he can delegate to other activities, and maybe someone who doesn't have any idea, maybe Laura, who works in marketing, now even understood the whole process of what Applied IT is working on, and she didn't even know 15 minutes before. And because in reality, if you see the dashboard, you don't need much knowledge to actually understand the dashboard. Just numbers, and okay, now it's going good or now it's going bad. And then Alexander, the engineer, or even Ima can work on talking to the engineer and seeing the changes. And then of course Ima may see the dashboard and see, okay, last week we tweaked the cameras, how is this going to affect on the next week, and that update. So basically that.
So small comment from my side. I think they hate me a little bit because I gave them very, very shitty data. No. I'm kidding, but one of the challenges of this project is this is real. This is the data that we receive when we are working on a process like this, and it's a lot of work and a lot of effort to really understand the data, to make it not only that you understand the data, to make others to understand the data, and I think you made it today, so it was great.
Yeah, the intention is to experience reality. No? Everything else in class can be very nice and clean when it comes to reality. But then if you learn everything in theory, but then you go to practice and you crash, that doesn't work. No? I want to ask the same question as well to as I asked the first group. No? You mentioned it would be nice to have more data, like you had hundreds or thousands of variables and you're still asking for more. If you could have gone back to January, which data would you have liked to record that you didn't have?
Well, I think it goes along the lines of knowing exactly what the data was. The main challenge was that you have a file that has a lot of columns, that we're talking thousands of columns, and you don't know exactly what each column means. So for starters, perhaps a glossary would have been very helpful. Then regarding the data in itself, I think some variables regarding what happened between the stations would have been very nice. For instance, we knew that from station A to station B, there was a process where the mechanic came and solved the issue that station A detected. So information regarding what exactly did the mechanic saw, what did he do, would have been very useful to understand exactly how station A is failing, and the same for station B. But I don't know.
I would have told myself to run away, but aside of that, the beauty of this project was to discover everything. And once you discover one variable, then you realize that the other variable affects the other variable, and then it gets, I don't know if you noticed, but it gets interesting, at least for us, and at least for me that I come from business, and then suddenly screws are interesting. So it was amazing to see that.
Great, guys. Thank you very much and congratulations. Whew. Feels good, huh? We're done. Good job. Now you see that it is true. Your expectations internally become super, 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 super high. You hate us increasingly, and then you present, and it's done. Like, this is good. This is a proof, as I said earlier, we did not know data science 5-6 months ago. No? Now you've seen what you just presented. You not only understood something. The first day you got the sensors data, like, what do I do with this? No? Like, here's this huge file with nothing to look into. Zeros and ones and decimal numbers. That's nice. Okay, now by the end of the project, not only have you understood it, you've understood the business process. You've been able to extract the data, clean it, build the model, evaluate the results, improve them, and finally explain it to someone who was not there. No? So I've said that you have to be a very good nerd at what you do to be able to enjoy it and do a good job about it. No? As you were saying now, Guillermo, like you find screws interesting. No? This is going to happen to every project you go into. No? One of the first things I want you to realize is that you've learned not only data science, you've learned that you can learn in such a short period of time. Now you've realized that if you wanted to learn something else in life, let's say I want to learn finance now. 5 months, I'm done. Of course, you're not experts in data science. Now, there's a long way to go if you want to work in the world of data science and a lot to learn. But you do have a good basis, no? And you're able to properly understand a full project, beginning to end, explain it to someone who doesn't understand, and make sense out of it. No? That's a huge improvement. So that's thing number one. I'd like you to remember that you've learned data science, but you've also learned that you can learn, and that's something to please keep it in mind in your life, because we're in a fast-paced, fast-growing world where new things keep coming up. And now it's not anymore this world where like, you'd study at university when you were 18 years old and then you'd never study again because you live out of it. No, that's not going to happen ever again, right? So we need to keep on updating ourselves, and I think you guys have done an amazing job at this during this program. I'd like to please get a full applaud for all of you in this aspect. So it was absolutely amazing. Thank you so much for the effort. And now I have something to ask. You guys have become, right now, part of the alumni network of this bootcamp. Most of the projects that come to us, they're projects that have somehow been related to us through the bootcampers, right? Some students, you guys now go to different companies and you start doing amazing projects, and then future students will want to learn from you. Right? Future students will want to participate. And a lot of the companies that collaborate with us come through students, right? So I'm happy to have you go out to the world, learn, explain, understand, and then try to keep on refeeding this feedback to the future students. So we create an amazing network of people that are able to help each other. No? What I said on the first day of the program, and I'll repeat today, you've learned a lot of data science, proven, check. You've learned how you can learn, proven, check. You're part of a community, but the best community you will have is your WhatsApp group that you guys have created, right? So that WhatsApp group with you guys, 5 years from now, you can still send, hey guys, have you seen this new update that is coming up? Like, this is super cool. Like, this will keep on happening. So please be part of this community. We do try to organize every now and then events for ex-bootcampers so everybody can meet each other. And this is super, super good for you guys to participate in this. And I'm very, very thankful that you guys have done so. So besides that, I just want to congratulate all of you for the amazing effort. It's been amazing to have you. And Marcelino, once again.
Yeah, thank you so much. Thank you for your effort, seriously. I'm very proud of you. I was very, very sure, 100%, that your presentations have been amazing. Congratulations. And you will receive a diploma, okay? And a digital diploma made with blockchain technology in a few days, okay? And now we have probably the most important thing today, the cocktail, okay? But before that, thank you to the audience. Thank you for coming. Thank you for the virtual audience. Thank you for watching. Thank you for the professors. Thank you for Barbara. Thank you so much, Ivan. Next intake will start next October, part-time in Spanish, and part-time in English. Next intake will start next February. Okay? And thank you so much, and have a good summer. Okay? And now to the cocktail.
Thank you.
A picture of us.
Vamos a hablar de contratos.
Chicos, poneros para la foto, por fin, en el frente.